60 years ago, Walt Disney looked at 27,000 acres of Florida swamp and saw the most magical place on Earth. The swamp saw something else entirely. It saw a temporary arrangement. Because here is what the history books, the promotional films, and the carefully managed Disney narrative do not emphasize. The ground beneath Walt Disney World was never meant to hold a theme park. It was cypress swamp, bayou hammock, and wetland as far as land surveys could measure. When engineers arrived in the late 1960s to begin preparing the site, they were not building on land. They were negotiating with it. 60 years and approximately $25 billion in infrastructure investment later. That negotiation is still ongoing. And occasionally, during an intense Florida rainstorm, the swamp reminds everyone who was there first. To understand what is actually happening when Walt Disney World floods, you need to understand what is underneath your feet when you walk through those parks. Because what lies beneath the surface is one of the most elaborate engineering systems ever constructed beneath a civilian entertainment facility. And even that system has a weak point. Start with the historical baseline, because it matters more than most people realize. In 1890, the land that would eventually become Walt Disney World appeared in Florida land atlases, with a classification that should give every Disney engineer pause even today. Nearly the entire 27,000-acre site was designated as cypress swamp and bayou hammock. These are not marginal wetland designations. Cypress swamp is deep, persistent, water-saturated ground where trees grow from standing water and the soil below has been waterlogged for centuries. Bayou hammock refers to slightly elevated hardwood islands surrounded by wetland, connected by shallow water systems that drain slowly and unpredictably. This land was not assessed as occasionally wet or seasonally damp. It was classified as swamp because that is what it was. Permanently, fundamentally, geologically swamp. The engineers who prepared the site for construction in the late 1960s understood this. They drained enormous portions of the property. They relocated water. They built retention systems. They fundamentally altered the hydrology of a significant area of central Florida in ways that remain one of the largest private land modification projects in American history. But modifying hydrology is not the same as eliminating it. The water that once sat in that swamp did not disappear. It was managed, redirected, and contained. And the underlying geology, the soil composition, the drainage characteristics, the water table behavior, all of it retained the memory of what the land had been. Every time it rains heavily in central Florida, that memory reasserts itself. So what exactly is underneath Walt Disney World, and how does the drainage system actually work? The most famous piece of underground infrastructure at the resort is the utilidor system beneath Magic Kingdom. Most guests walking down Main Street, USA are not aware that they are not walking at ground level. The entire Magic Kingdom was built elevated on a platform above a network of underground service corridors. These utilidors, a portmanteau of utility and corridor, allow cast members, supplies, and waste to move around the park without crossing the guest experience areas. The practical consequence of this construction approach is that Magic Kingdom sits on what is effectively a second story. The ground-level utilidor network below it contains mechanical systems, service areas, and critically for our purposes, the beginning of the drainage infrastructure that handles water falling on the park above. Below and connected to this system runs an extensive network of drainage pipes, some reaching up to 5 feet in diameter. 5 feet. These are not the pipes you picture when you think of ordinary storm drainage. A 5-foot diameter pipe can move enormous volumes of water rapidly. The engineering capacity to shift water away from the park surface and into the broader drainage system is, by any normal standard, impressive. The canal network surrounding the resort properties extends this capacity further. Disney's retention ponds, which are numerous across the property and frequently integrated into the landscape design as decorative lakes, function as the final stage of the drainage chain. Water moves from the surface into pipes, through pipes into canals, through canals into retention ponds, and from retention ponds into the broader Florida water management system. On paper, this is a system with substantial capacity for handling significant rainfall. So why does it flood? This is where the engineering reality becomes interesting, and where the specific weak point in Disney's drainage chain reveals itself. The answer is catch basins. A catch basin is the surface drain, the graded opening at ground level that captures water from the surface and directs it into the underground pipe network. It is the entry point to the entire drainage system, and it is, by necessity, limited in how fast it can accept water. Consider the physical constraint. A catch basin opening has a fixed surface area. Water can only enter through that area at a rate determined by the opening size and the depth of water above it. The pipes below the catch basin can move enormous volumes of water once they receive it. The retention ponds can store enormous volumes once they receive it. But before any of that capacity can be utilized, the water has to get through the catch basin opening first. During a typical Florida rainstorm, even a fairly intense one, the catch basins can accept water fast enough to keep the surface from accumulating significant standing water. The system functions as designed, but Florida does not always produce typical rainstorms. Central Florida sits in one of the highest lightning frequency zones in the United States. It receives more annual rainfall than almost any other region of the continental country, and it regularly produces rainfall events that meteorologists describe with terms like training thunderstorms, where a series of intense storm cells stacks up and moves over the same area repeatedly, or stationary convective systems that drop enormous quantities of rain over a small geographic area in a very short period. When those events occur over Walt Disney World, the rainfall rate can exceed the capacity of the catch basins to accept water. The pipes below are capable of handling the volume. The canals and retention ponds are capable of handling the volume. But the catch basins become a bottleneck. Water arrives at the surface faster than it can drain through the available openings. The result is surface flooding. Water accumulates on walkways and low-lying areas around ride entrances and exit points. Guests wade through ankles of standing water. Iconic photos emerge of Main Street, USA, with several inches of water flowing down it, or of Liberty Square living up to its occasional nickname as Liberty Swamp. The system has not failed. It is working correctly. The underlying pipes and canals are accepting every drop that the catch basins deliver to them. The limitation is specifically and only at the surface drain entry point. This distinction matters enormously for understanding why Disney has not simply fixed the problem. Because here is the engineering and business reality that Disney's management has clearly calculated and concluded. The catch basin bottleneck can be addressed. Engineering solutions exist. You can increase the number of catch basin openings across the park surface, increasing total intake capacity. You can regrade sections of the park to direct water more efficiently toward existing drains, reducing the accumulation depth at any single point. You can add supplementary surface drainage channels that move water laterally toward drain concentrations, rather than relying on gravity and surface slope alone. These solutions work. They are not technologically exotic or beyond Disney's engineering capability. Disney employs some of the most sophisticated theme park engineers in the world and has demonstrated repeatedly the willingness to execute enormous, expensive infrastructure projects when the business case supports them. The business case here is the complication. Significant flooding events at Walt Disney World are not daily or weekly occurrences. They are episodic. They happen during the specific kind of extreme rainfall event that Central Florida produces occasionally, not routinely. For the vast majority of operating days, including the vast majority of rainy days, the existing system handles rainfall adequately. The cost of substantially increasing catch basin capacity across a property the size of Walt Disney World, regrading significant areas of theme park surface while keeping the parks operational, and disrupting guest experience during construction is enormous. It would require years of planning, significant capital expenditure, and periods of visible construction activity in areas guests paid to experience as immersive and seamless. The return on that investment is the elimination of flooding events that occur rarely and, from a business continuity perspective, do not typically cause park closures. They cause inconvenience. They generate social media photos. They occasionally require temporary closure of specific attractions for safety assessment. But the parks continue operating. Guests continue their visits. Revenue continues flowing. The cost-benefit calculation that Disney's engineers and financial planners have clearly made is that the frequency and business impact of flooding events does not justify the capital and operational disruption cost of eliminating them. The existing system handles the vast majority of situations adequately. The rare extreme event produces manageable inconvenience rather than catastrophic operational failure. This is not a criticism. It is rational infrastructure economics applied to a specific situation. Every infrastructure system in the world is designed to handle a defined level of stress, with the design level determined by balancing the cost of higher capacity against the probability and cost of capacity being exceeded. Disney has made a business decision about where that line sits for their drainage system. The swamp occasionally disagrees with where they drew the line, which brings us to the framing that makes the Disney flooding story more interesting than a technical drainage lecture. The relationship between Walt Disney World and the land it occupies is not a story of conquest. It is a story of negotiation. An ongoing, never fully resolved negotiation between human engineering ambition and geological reality. The engineers who built this resort did not defeat the swamp. They proposed terms to it. They said, "We will drain you here, redirect you there, contain you in ponds that we will call lakes and integrate into our landscape design. We will build elevated platforms so our guests walk above where your water table sits. We will move your cypress and your bayou and give you this contained space to remain." And the swamp, for the vast majority of days, accepts those terms. But Florida weather occasionally produces conditions that test the agreement, conditions under which the negotiated terms cannot fully hold. When rainfall exceeds what the catch basin openings can process, the swamp briefly reclaims a portion of what was taken from it. The 1890 land atlases described this ground as cypress swamp because for centuries, this is where water came and stayed. The soil composition, the drainage characteristics, the water table behavior, all reflect that history. No amount of engineering fully erases what the land was, because engineering works with physical reality rather than replacing it. What Disney built is genuinely remarkable. The scale of infrastructure investment, the sophistication of the drainage and utility systems, the sheer audacity of constructing a permanent entertainment complex on a Florida swamp and making it work for 60 years, deserves recognition as a genuine engineering achievement. But the swamp remembers, not with malice, not with any intention whatsoever, simply with the physical properties of soil that was saturated for millennia, of water tables that seek their historical levels, of rainfall that falls at Florida, intensity underground that has not forgotten what it was before the engineers arrived. Every time guests wade through standing water on Main Street, USA, they are experiencing a brief, harmless reminder that the most elaborately engineered entertainment environment in human history is built on a truce with a swamp that was there long before the magic and will be there long after. The question is never whether Disney has conquered the land. The question is whether today is a day the swamp agrees to the arrangement.